We're making devices, software and hardware that can read human emotion in virtual reality, augmented reality and the real world. We've got two devices here. We've got the emteq Pro device, as you can see, is just a mask with integrated sensors, electromyographic, so they can detect the muscle activation of the underlying muscle of the face. We've got them situated in the most strategic locations in order to extract emotional states. And we've got extractable sites for narrow and wide faces, and an integrated photoplethysmographic or PPG sensor onto the forehead. And inside this box here, the AC converter, we've got a smart IMU, inertial measurement unit, that can track high resolution movement. All of these signals together are streamed directly into our app, the Supervision app, that I will show you how it works. This fits directly into the Vive, and we can also wear it as an open face, which we will do now with Adam's help.
Okay.
Let's see how
well it's set up for myself.
Yeah.
Okay. I have got quite a small head, so I'm gonna have to have it.
We've got the narrow inserts on.
Okay.
Perfect. So normally with EMG systems back in the day, we would have these big, chunky, wet sensors that we would put on the face. But now we've got dry sensors, which means that you don't need to do any skin preparation. It's minimal, basically. And then easily, instantly, you've got really good skin impedance. All of the sensors now are in good contact with the skin. Everything is green. If you move one of the sensors, like Adam is going to do now, you will instantly see a change in the impedance, which will be visualized in a very easy traffic light sort of way. Once you're ready with the setup of the mask, then you can start streaming the data in real time. We've got electromyographic on the top, all of the signals directly outputted here. This is the RMS, so the root mean square of the signal. EMG contact is the impedance, which is nice and low. And then we've got the PPG output here, which in the case is not actually very powerful, but you can still see the systolic peaks. This is the raw signal, so after the filtering, we can extract heart rate variability, breathing rate, many other metrics that are really useful for stress detection. So with the EMG here, if Adam gives us a very big smile, you see some big activations, especially around the zygomaticus, which is the cheek area, the eye area, and not so much on the forehead. By comparison, when Adam will stop smiling and will give us a nice big surprised expression, we will see more activation on the frontalis and slightly on the corrugator channels. The same thing when you give us a frown, like you're angry, you will see a lot more activation on the corrugator. Once you apply our algorithms that we have been building for many years now, with lots of data sets, we've run many studies, 800,000 data sets in the past, we're able to extract affective information, cognitive states, and behavioral observations from that. We use contextual information together with behavioral traits to get a better idea of what the user is doing and how they're feeling towards a stimulus. And I think that plays a very important role in VR, and that's why we've got an SDK.
Yeah, so all of this information that you can see here, we have a SDK for Unity, as if you mentioned, and that information can be fed through to the VR environment, which allows developers then to use this information to react to changes in how the participant is responding, to change something in the environment, change something in the scene. So something that might be used as an example is that you would have, if you have a horror game, for example, where you would have a zombie that approaches, and if you see within the reaction there that the user is not responding as you would have expected, maybe they're used to zombie games, well, you can really amp up the environment. You can throw in a bigger monster, more monsters, to get the kind of reaction that you were intending to get out of it. So we are integrated into the Pico Neo 3, as you can see here. And we also have integrations to the HTC Vive Pro and the HTC Vive Pro Eye to allow eye tracking. And yeah, all this is downloadable from our website. So we have all our documentation, all our SDK assets online. So as soon as you get the hardware, all you need to do is download the assets and the software that we provide to be able to start experimenting with our data.
Oh, let's not forget our glasses.
Yeah.
We've got this alpha version, a bit bulky at the moment, however, it's got the same sensors inside. It's called optomyographic. There's optical sensors located on the strategic locations around the face, and it can track the muscle activation without being in touch with the skin. And we have patented those sensors. They are minimal, they don't require a lot of energy, and they get very high resolution signal, but only a 10-fold of the EMG, which means that they can run with very low battery.
Yep.
And we've got a demo here, so you can come and visit us and see how we can extract facial expressions from just wearing glasses.
Yep, and you'll be able to see in real time using the iPad demo that we have here. So there's many different use cases that we have for this technology. So from medical, we're using it in a study to be able to treat anxiety, PTSD, for example. Also analytics, being able to verify the content that you're creating matches or exceeds the intention that you had. So if you have different scenes that have you intended to be more exciting, less exciting, more shocking, you would be able to plot those ahead of time and see how well you were meeting those expectations. Also, do you want to go to other use
At the end of
cases?
the day, our vision is to help people and save lives and help manage something that is not so easy to detect early on. So our idea is, especially now, we're doing a lot of studies with the detection of depression and for Parkinson's as well. So there are a lot of different use cases where these data could be utilized, and it's really, really important that we start building those strategic models that will help and encourage people to train and manage their life better and manage their illness or their condition more.
Yep.
And in the future, I can see a lot of interventions, healthcare and well-being, where
Yep.
they will feed back onto the glasses, maybe a vibration, maybe some light, something that will give users the confidence to get out in the real world, walk easily, do their activities, and have more confidence.
Yeah,
with
it's
the
all
social
about
life.
self-improvement. So given the data that our glasses and our mask can measure, we can use that data to help better inform people about their own lives, basically, so they can work towards better behaviors and improving their health.